what I'd like to do is walk you through the process of determining how the app and the grid should be laid out. And I want to start with this description of an AC app. And it's in portrait mode here because the particular example I'm going to work with is a portrait mode app. But this whole image here occupies the screen of the tablet. So from here to here is the screen width, and again we're talking about portrait mode, so the width is going to be narrower than the height. And this whole length here is the screen height. There's an upper message bar potentially, an upper command bar potentially, and the same for lower message bar and lower command bar. The app is the entire length of the screen height. The grid is just this portion between the command and message bars. And there is the traditional grid of buttons that you're used to, but there also may be a range of real estate outside of the grid of buttons, but still within the overall grid that's set aside for padding. And we'll see some slides later as to why that's valuable. So when you see padding, it's referring to this region outside of the buttons, but still within the bars, still inside of the two bars, the lower message bar and the upper command bar. It's still within the grid. And if I haven't already done it by the time you see this video, I will have moved all the padding options inside the grid layout rather than where they are currently in the app layout, just to drive this point home. All right, so now let's talk about how buttons are laid out within the grid. So they can be in two basic forms. Either they're balanced within that space or they're unbalanced. These two images here are an example of balanced button layouts. What I mean by that is that either, and these are really sort of the two cases, you'll see buttons that where the array of buttons stretch from one edge of the grid to the other edge of the grid, one edge of the screen to the other edge of the screen, and from the lower message bar all the way up to the upper command bar. So that entire region in the middle is totally occupied by buttons. And there is really no space between buttons either. The buttons in the left column reach all the way to the edge. There's no space on that side between there and the edge of the screen. A second one would be a layout like this, where the buttons don't necessarily themselves reach all the way to the upper and lower bar regions or from side of screen to side of screen. But if I look carefully at the distance between the buttons and I divide that distance in half, I'll see that that's roughly the distance from the leftmost button to the leftmost side of the screen, or the rightmost button to the rightmost side of the screen. And the distance between buttons is also about the same. The distance vertically between buttons is almost exactly the same as the distance horizontally between buttons. So both of these are balanced button layouts. We'll see in a moment that these kinds of layouts don't require padding. Where padding is important, it's in the next set. But let's take a look now at if I were to put a typical grid of rails on top of both of these layouts. They fit perfectly. Okay, so this is, believe it or not, the exact same grid up here as it is down here. Same rail width in both cases. This is a 4-column, 5-row grid. But there's the exact same in essence, key guard on top of both of those layouts. Here are a couple of unbalanced layouts. So in this case, we have the same number of buttons in the same number of columns and rows, but they are arranged tightly to each other, but there's a lot of space around them. Pretty much a consistent amount of space around them on all sides. Or those could be shifted slightly in the space of the grid region of the screen. And you can find them with, again, equal distances horizontally between buttons and vertically between buttons. But the space on either side, between that and the edge of the screen, or between that and the upper and lower message and command bars, does not match at all. The distance between the buttons is larger than simply 1/2 of the distance between buttons. And it can be asymmetric like this, where top is small, bottom is large, right is large, left is smaller. They're just kind of shifted in this space, but it's still not a balanced use of space like the other ones. Now, if I take that same layout of rails and place it on top of these grids, we'll see some obvious problems. So in the upper case, things align pretty well in the center, but the buttons themselves are smaller than the openings in the grid, significantly smaller. And their edges are misaligned. So pretty much there's only one point of between the buttons that aligns with a rail. This is what it looks like when that same rail layout or key guard is applied to the second one. And since these rails are laid out from the corner of the grid, unless there's some sort of padding, they're laid out evenly from the corner of the grid here, both horizontally and vertically. This is what you will get. If you just say it has 4 columns, 5 rows, and you don't specify padding, this is what you'll get. It tries to use that space as evenly as possible. So how do we address this? Well, what we do is we add padding. And in the first case, we're going to add padding that fills in that extra screen real estate around the edges. In fact, in this case, all the padding would be the same size, top, left, right, bottom, it'd all be the same size. And now the rails, they align really nicely. I can take it away here and you'll see that there's the underlying grid. There's your key guard on top. There's your underlying grid. We just took that key guard with the extra padding, lay it on top. That is the purpose of padding. So when this grid of rails is laid out, or these rails are laid out, they're laid out relative to this point. They take this point here about halfway through the width of a rail, top and bottom and left. So right about there. That's where they're evenly laid out. Same in this case, and that is taking into account the padding, bottom padding, left padding. And this one is laid out starting here. So let's take an actual example. This is the Cough Drop app I just got a screenshot from today. And what we see here is an app that has 4 columns, 4 rows. At least that's how it's configured in this particular case. It has sort of a status bar that you see in most or all iPad apps at the top. Then there's an upper message bar. And then we begin the tiles right away, the buttons in the grid right away. I was given this screenshot. It turns out that I learned something new with this one, that under certain circumstances, the screenshot that's taken and saved as a file will be 640 by 480 rather than what I have on the web page. I don't even remember what that is right now. So a different number of pixels. And therefore the conversion factor that's used has to be different. So this application is going to be running on an iPad Air 2, which has a screen that is 203.11 millimeters high and 153.71 millimeters wide. So if we just convert the number of pixels in the screenshot to the amount of real estate that it actually occupies on the tablet, that conversion factor is there's about 0.32 millimeters for every pixel. And so we can measure the number of pixels on this screenshot and then do the conversion to say how many millimeters of actual screen real estate will that take up. All right, so next we'll take a look at what regions of this screen do we want to be measuring. So I want to look at several areas. I want to look at the horizontal and vertical distances between buttons. I want to look at the horizontal and vertical distance between buttons and the edges of the screen. And the same up here at the top. I want to see from the top of the buttons to the top edge of the button area, what that distance is. And then I'll grab these distances as well, how large this upper message bar is, and I'll even look at the status bar on the app. So first we're going to look at this region of the app, one of these intersections of buttons. And the way I do that is I just use Microsoft Paint, and you may or may not have access to Paint, but maybe you have access to another app that allows you to do these sort of pixel measurements. And this is 480 pixels by 640. Should be 640. Why does it look like it's more? Yeah, it is. 640. Okay. And as I move the mouse around the screen, you see these little crossbars that appear. And what's important is what it reads down here in the status region. As I move it around, I want you to watch that region of the screen. It's a 480 by 640 screenshot, but let's see what the readout is here as I move it around. So if I hold the mouse right about here, what I see is 321 pixels from the left and 58 pixels from the top. And it's hard for me to measure given the small size of this, so I'm just going to go ahead and make it larger. I'm going to zoom in on it a couple of times. And I'll just scroll down a bit to get to those buttons we were looking at in the PowerPoint slide. But so if I look at the bottom of this button right here and then read in the status region on the far left below, try to pick sort of the middle of this guy, it's about 490 pixels from the top. That just gives me a starting point to measure the distance across this. And the distance across is 497 minus 490. So it's about 7 pixels between buttons. And if I do the same here with the vertical edge of this button, get into the middle of it. It's about 117 pixels from the edge of that to 124 pixels to the edge of this one. Another 7 pixels. So the spaces between the buttons are about 7 pixels. let's go back to our screen here and verify that that's what I wrote. So it was 490 to this point, 497 to this point. The difference between the two is about 7 pixels. 117 to here, 124 to there, about 7 pixels again. So very consistent, and that's the way most apps are laid out. Very consistent distance between buttons. It's just easier to do from a programming standpoint. All right, now we're going to look at this upper region up here and go back to Paint, scroll up. And this is something I kind of discovered. It's going to be hard, maybe hard for you to see, but there's a very faint line here that's going horizontally across the screen, right about where my mouse is. And I don't know if they intended to put that in there, but it is actually the button region. So it's not part of this upper message bar, it's part of the button region. So we can look at how far down is that little line, and it looks to be approximately, let's see, about 56 or 57 pixels. And then to the top of the next button, we're looking at 62 pixels. So 62 minus 57, that's 5 pixels is the distance here. So that's also, so we had 57, 62, and just curious, what is the height of this, or the distance of this status bar? It's roughly 13 pixels in width. Or height, I guess, in the terminology we use here. Go back to our PowerPoint presentation, and so this is about 13 pixels. Is 57 to this very faint line that you may or may not have been able to see a minute ago, and 62 pixels to the top here. 62 minus 57, about 5 pixels above the top button. And we'll just remember some of these other things for later when we're sizing for message bars. All right. Last thing we're going to look at are these distances on either side of the buttons and the distance below the buttons to the edge of the screen. So I'll scroll down, and I put my cursor right about here. 477 from the far left edge. We know this is 480 wide. In fact, if I try to put my mouse right on the edge here before it changes form, that says 480. So there's about 3 pixels on this side. And while, yeah, we'll just scroll over to the other side right now. Let's see. Oh, I'm already over there. What am I saying? If I put my cursor here and keep it there, it's about 4 pixels to the edge of this. So 4 pixels on the left, 3 pixels on the right. How many on the bottom? So the bottom of this button and the bottom of all these buttons on the bottom row is at about 635 pixels. Well, it's a 640 pixel high image, so the distance here from the bottom of this button to the bottom of the screen is about 5 pixels. 4 on the left, 3 on the right, 5 below. Four pixels on the left, 3 pixels on the right, here in the red, 480 minus 477, 5 pixels on the bottom, 640 minus 635. So this is really where we are as far as the grid of buttons region of this grid layout. And using our conversion factor that we had earlier, which was 0.32 pixels per millimeter, then I can translate each one of these into millimeters as well. 5 pixels is 1.6 millimeters. But let's think about this a little bit. We said that a well-balanced grid of buttons has the distance between buttons about twice the distance from the buttons to the edges. Well, half of 7 is 3.5, which is darn near 4 and darn near 3. On the other hand, it's, if I take 3.5 subtracted from 5, that's off by about 1.5 pixels, or little less than half of a millimeter. So you could, I wouldn't bother padding left or right. Those look very close to being perfectly balanced. You might say, oh, maybe I want to put a millimeter. I don't know, but we're only off by half a millimeter. You could theoretically want to put a half a millimeter or a millimeter of padding at the bottom and the top, but I just don't think it's worth the effort. And you can't put a half a millimeter because the program only accepts full millimeters. So I think in this case the best thing to do would just simply be to go with no padding anywhere on this app. Last thing to talk about is what do you do as far as message bars? And what we see here is that the distance from the top of the screen to the bottom of the message bar is 57 pixels or 18.24 millimeters. And remember again, the program only accepts whole millimeters. So there are a couple of things we can do. We can include this status region as part of the message bar. And that means that the message bar would be the full 57 millimeters in height, approximately 18 millimeters high. Did I say millimeters before? 57 pixels in height, 18 millimeters. Alternatively, if we wanted to cover this, or if we were just looking for additional thickness up top, you might say, well, what if I actually treated this as a command bar, treated this as a message bar, said the upper message bar was 4 millimeters high, the upper command bar was 18 minus 4 or 14 millimeters high. I'm going to expose the command bar but not the message bar. Then I'd get some additional thickness up here. We'll see if it's necessary. So now that we have all these measurements, we can go ahead now and fill out the data form. So our target iPad is an iPad Air 2. We're going to use it in portrait mode. We're going to uncover the home button and uncover the camera. We do have a case. And what I have data-wise is that the opening in the case is 210 millimeters high and 155 millimeters wide. And remember, we're in portrait mode, so we would expect the height to be larger than the width. Let's go ahead and just include the status bar along with the message bar. And we'll just say, yes, we have an upper message bar, and it is 18 millimeters high. There is no upper command bar, no lower message bar. As I said, we're not going to mess with any padding because it just doesn't seem to be that significant here. If anything, top and bottom, but it's so minor, it was like off by 0.5 millimeter. How many rows? We had 4 rows, 4 columns rather, and 4 rows. The rail width, we know there's about 2.5, what did I say? 2.5 millimeters between. I went too far. There's 2.24 millimeters between buttons, so we could go down as low as 3 millimeters here. And the rail slope, well, we have several options here. I'm just going to propose that we go at 60 degrees for now, and we'll take a look at what the effect of using other slopes might be. We're not going to change the shape of openings or do anything else, but we're already going to say that this is going inside a case, and we're going to use the raised tabs for it. And these would just all be measurements we took off the case. 14 millimeters in height, 20 millimeters in width, and we want those tabs to be about 3 millimeters thick. Okay, so now that we have this all filled out, we can save it, send it off, or just use it for our own purposes when we bring up the keyguard.scad either in the customizer on Thingiverse, or we use the OpenSCAD program right on our PC. And my PC is old, so it doesn't do rendering very nice in real time. We have to choose it separately to see a nice render. So we're just going to go ahead and put the data in, and then we'll do a render, and we'll see what that looks like. So we'll enter all the same data we put in our data sheet. iPad Air 2, portrait mode. We're not going to cover the camera or that, or the home button. We're done with the tablet region. Tablet case. Yes, we have a case. It is 210 high and 155 wide. We're done with the tablet case region. In our app layout, we do have an upper message bar. It's 18 millimeters high. We are going to display it. And that's really it for this region. We're not planning on adding any padding. And as I say, this, when you look at the keyguard.scad soon, this whole section here will be moved to grid layout, just to reinforce that that's part of the grid, not part of the overall app. Done here. Grid layout, columns is correct at 4, but we have 4 rows. Our rail width, we're going to just go ahead and take it down to 3 for the fun of it, because we can go that thin. And we'll leave the slope at 60. If I look down here, I see this is an overall rail height of 2.5. I hate to go below 3, but what the heck, let's give it a shot. The way I can make that taller is simply by making the rails thicker. This is the minimum rail width, or changing the slope to a higher slope, like 80 or 90 degrees. Then the last thing we need to do is set up the mounting. We'll go with raised tabs. We'll choose a raised tab height of 14, a width of 20, and a thickness of 3. It's already at 3, so we're done there. All we have to do now is render it to see what it looks like. Okay, here's our case as we, or not our case, our keyguard as we've defined it. This should align very nicely with the buttons. In the app, this should be plenty of space for the upper message bar. In fact, we even have a little extra space for the status bar. The case fits very closely to the screen, so these outer rails are relatively thin, but then we're only 3 millimeters in general. Since this is going inside a case, it may look a little fragile, but it's probably not a problem while it's inside the case. Once it's out of the case, you'd want to be a little more careful with it, just to make sure it doesn't break on any of these thin edges. We see that the top appears even thinner than the rails themselves. couple of things one could do to affect this would not be padding necessarily. This is where you might want to go in and simply say, I want to add additional width to this case. It's plenty thick enough on the top and the bottom here, but I might want to add some additional width compensation on these two sides, and it's going to bite into the space for these outer buttons, but these are big buttons anyway, so maybe not an issue. It won't change the position of these vertical rails to do that, so they'll still align well with the buttons. You could make the rails a little wider. That'll make this slightly wider on either side. You could, probably the way to have the greatest effect is simply to change the slope of everything to 90 degrees. I'll go ahead and do that now. So with a 90-degree angle on the cells, we have sufficiently more thickness here. This is still relatively thin up top. Not much that can be done here again without going in and adding width compensation for this tight case. One more thing I want to show you is what happens if I wanted to add that, where is it here? If I wanted to add a bar edge slope. So right now this edge of this upper message bar is 90 degrees along this face. So it's straight down. If I were to change that to something at a greater angle, or less of an angle actually, say something like 60 degrees, let's take a look at what that effect would be. So now we have trimmed that off at an angle of 60 degrees, and if I zoom in, I've actually cut into these vertical rails, and what I have left over is a very thin slice between the top button and this upper message bar. I'd be uncomfortable with that being what holds the tops of these rails in place. And this is a keyguard that is relatively thin vertically, and so I don't know that having this angle here, it's also a very open message bar, so I don't know that adding that angle there adds much to the visibility or accessibility of the upper message bar. I think I would rather want to stick with the 90-degree slope here, rather than go 60 and produce something that's much thinner up here. And that's a problem you're simply going to run into anytime you have an app like this with the buttons starting right up against one of the message bars or command bars, and you're exposing. So anytime the buttons sit right against an exposed area, there's going to be a very thin piece of the keyguard here. So in those cases, I would avoid sloping the bar itself. All right, so that's the last I wanted to say about laying out your app, taking measurements, making decisions about widths, and especially about where padding is useful and where it's not.